Oh God. Can you hear me? Sorry. Let's begin because time is fast spent. We're supposed to start at 9 o'clock. So, sorry. Very sorry. So now this session we are going to deal with complex numbers. Complex numbers. Yeah. So I've divided the topic into five subtopics. The first part will be what is complex numbers. Ignore the handwriting. What are complex numbers or what is a complex number? The second part is operations in complex numbers. The addition, subtraction, multiplication, operations. Third one is the argument or the angle and the modulus or the absolute of a complex number. The fourth one is the polar representation. Polar representation. And what we are going to do in the operations up to the absolute will be under the rectangular representation, rectangular form of representation. And after the polar, we'll move on to the De Moivre's theorem. Then the Taylor's expansion. We just talk a little about it. Then last is the Euler's notation. Euler, sorry. Now, what's a complex number? A complex number is any number that is in the form of, let's say, if Z is a complex number, Z is a complex number if it's in the form of A plus IB, where A is the real part. Real part. This whole place is the imaginary part, but B is the imaginary part. So you're wondering what this I is. The I is just like, it's just a symbol, square root of -1. That's it. It's just an imaginary unit. It represents square root of -1. And whenever you're writing a complex number, usually the I comes before an alphabet. So it's A plus IB. And if you want to write it with a letter, with a number, it's going to be like maybe 2 plus 4i. So it comes before the number. It comes after the number. Now, we are done with what complex number is. Now we are moving on to the operations in complex number. Let's start with addition. Addition of complex numbers. So let's assume Z1 is a complex number in the form A1 plus IB1. And Z2 is a complex number with values A2 plus IB2. If you want to add Z1, I'm so sorry about that. So sorry about that. But if you have any questions, you can comment in the chat section. You can write your comments in the chat section. Okay. So assuming we are adding z1 plus z2, z1 plus z2, that will become a1 plus ib1. That is for z1 plus a2 plus ib2. So in adding complex numbers, you add the real parts to a real part and the imaginary parts to an imaginary part. So you add this part to this part and add this part to this part. So it's going to be a1 plus a2 plus ib1 plus ib2. Here can be, if you can factorize the I out, so it becomes b1 plus b2. That's all for the addition. So now we can solve some questions. Let's say given z1 is equal to 2 minus I, and z2 is 3 plus 4i. 3 plus 4i. And you're supposed to add z1 to z2. This becomes 2 minus I plus 3 plus 4i. So you're adding imaginary parts to imaginary parts, real parts to real parts. So 2 plus 3 minus, because this, minus I plus 4i. So 2 plus 3 is 5. Negative 1. Let's let's factorize the I out so that we won't get confused. Plus 4. So this becomes 5 plus negative 1 plus 4 becomes 3. So 3i. So this will be your final answer. It's simple. ABC. That's for the addition. Adding real parts to real parts, imaginary parts to imaginary parts, and get a final answer. It's the same thing with the subtraction. Yeah. The same thing with the subtraction. So a1 plus ib1. There's z1. Then z2. a2 plus ib2. So z1 minus z2. You're going to subtract this from this. So let's write it all. Right. Minus. With the subtraction, you have to be very careful. So this becomes a1 minus a2. Then plus b1, ib1 minus ib2. We can factorize the I out, so b1 minus b2 plus a1 minus a2. That's it for the subtraction. So we can take a question for that one too and try our hands on it. Let's pick the questions. That's one equal to 3 plus 4i. That's 2 equal to 2 minus I. So z1 minus z2 becomes 3 plus 4i minus, the negative is affecting the whole of z2. So it's going to affect everything here. That's why I brought a bracket. You have to be very careful. So this becomes 3 plus 4i minus 2. The 2 affects this. This becomes plus I. Adding real part to real part. 3 minus 2. If subtracting real parts, like, yeah, you are separating them, grouping like terms. Plus 4i plus I. This becomes 1 plus this. What meaning? No. This plus this 5i. That's all. If you have any question, you can type it in the comment section. Now, multiplication and division. Let's do division first. Division of complex numbers. For the division, it's, I won't say confusing, but you have to take your time before you do the division parts. Because first, before I explain the division, you know how to find the conjugate of a complex number. Let's say that is a complex number with values a plus b, a plus ib, a plus ib. So the conjugate of a complex number, you're just going to change the sign over here. So a minus ib, that will be the conjugate of the complex number. That's all. Like you're just changing the sign from positive to negative, the sign of the imaginary part from positive to negative. Yeah. This one we are going to just start with an example. Z1 it's equal to 2 minus I. Z2 equal to 3 plus 4I. Now we want to find Z1 over Z2. Let's do Z2 over Zi. So Z2 over Z2 3 plus 4I all over 2 minus I. For division, you need to clear this complex number from the denominator. So by doing that, you need to multiply the whole fraction by its conjugate. You need to multiply the numerator and the denominator by its conjugate, by the conjugate of the denominator. Yeah. So that becomes times the conjugate of 2i minus 2 minus I becomes 2 plus I over 2 plus I. So we are going to multiply it. You can see the multiplication in this. For multiplication for in complex numbers, it obeys the distribution property a plus b, d plus d. So a would multiply c, a would multiply d, b will multiply c, b will multiply d. That's for complex numbers. It's the same as the distribution property. So that becomes 3 plus 4i multiplied by 2 plus I. And the denominator becomes 2 minus I multiplied by 2 plus I. So this becomes 3 times 2, 6. 3 times I plus 3I. 4 times I squared becomes square root of negative 1 squared. That becomes negative 1. So that means 4i times I, 4i times I becomes 4i squared. And we know I squared is equal to negative 1. That becomes negative 4. Negative 4, yeah. So this here becomes negative 4. All divided by 2 times 2 is 4. 2 times 1. 2 times 1. 2 times I is 2i. Now, negative I times 2, negative 2i. And negative I times negative I times positive I. That becomes negative I squared. And I squared is negative 1. So it becomes negative 1. That becomes plus 1. You've seen something here. When you multiply a complex number, maybe Z1, by its conjugate, Z1 prime, it becomes the squared of the real part, A squared, plus the squared of the imaginary part, B squared. So here, 2 squared, that's 4. Because this is going to cancel this, like it's going to equate to 0. So 2 squared, that's 4, plus the imaginary part, that's the conjugate of the imaginary part, that's 1. So 1 squared, that's 1. So you get simplifying the numerator. 6 minus 4, that gives you 2, plus 8 plus 3, that gives you 11. I all over 4 plus 1, 5. That's all. Or you can simplify it further. 2 over 5 plus 11 over 5i. Okay. Now with division. And in a division, we learned about multiplication, because without multiplication, we wouldn't be able to do this part. And please, if you have any question, you can ask in the comment section. Yeah. Or if you have any problem, you can ask. You can notify me in the comment section. Next on the list, we are moving on. Next on the list, we are moving on to the argument and modulus. Yeah, clear. Arguments and modulus. Okay, so for complex numbers, argument is just like the magnitude or so. Yeah, the magnitude. A modulus is like from the complex number. Let's say z. Can you hear me? Now we can continue. We are on the modulus of a complex number. The modulus of this complex number, it's square root of a squared plus b squared. That's all. That's the modulus or the absolute. Now we are going to the arguments. Argument of the complex number is the theta, the angle from the complex number. Angle from the complex number to the real part. That's the theta. Theta will be equal to tan inverse trig or trig. You see that it will form triangle. You can see that it will form a triangle with here being your complex number, here being your A, and here being your B. Opposite over adjacent. Tan inverse of B over A. That's for your argument. Argument or your angle. The angle your complex number makes with the real part, the real axis. And one thing. You, as we solve questions, would see how it goes. Let's take this question. Z equal to negative 2 root 3. Z is equal to negative 2 root 3 minus 2i. You are supposed to find the arguments on the modulus. So for the modulus, is the absolute. That will be square root of a squared plus b squared. So your a here is this, and your b is here this. Your a is negative 2 root 3, and your b is negative 2, because the equation of a complex number is a plus bi. So your a goes with this, and your b goes with this. So that will be negative 2 root 3 squared plus negative 2 squared. Input it in your calculator. You'd get 4 here, root 16, which is 4. That'll be your absolute. Yeah, your absolute or modulus. So 4 units. It's a distance. Now going on to your argument. The argument or your angle. If you are supposed to plot this complex number on the real imaginary axis, wait, this is the imaginary part. So negative 2 root 3. Negative 2 root 3 gives you 3.46. So this is your real axis and this is your imaginary axis. So negative God. Sorry, the video keeps lagging, so I think we should end it, and maybe we might do it in person on Saturday or another time. I'll try and find a better network, or if I can't, we might do it in person. So about to end the stream.